the amounts which you have seen, like 60 and 70, that was not there in the chart, sir.
Okay.
So now it is
Hello.
live
We
stream.
can start now. We can start.
Okay. I did not get any code from my side. I believe it will be automatically started.
Yes, sir. Yes, sir.
Okay, okay, great.
Lakshmi, you are moderating?
Yeah.
Hello.
Lakshmi sir, please start. So I think there are some issue with Lakshmi sir. So now I am starting the session. So first of all, I would like to invite Professor Ajit Tyagi sir for a special address.
Thank you, Divya, and good afternoon, Bhatia Saab, Somesh, who is traveling but has joined us, and all organizing committee members, and Shibin, of course, our speaker today, and all the participants. We are meeting on a pre-Christmas weekend, so I think attendance is a little thin, but those who are attending are most welcome. I think they are the keen enthusiasts. And today's lecture is going to be very, very helpful in developing practical understanding of satellite meteorology with respect to the tropical cyclone monitoring and prediction. Shibin, in his previous lecture, has given a background about tropical cyclone. The participants who are not familiar per se with the tropical cyclone climatology or synoptic and dynamic features, he has covered. He has also introduced the satellite part a little bit, also in the last lecture. And today, as I see from the coverage which he is going to do, is to cover practical aspects of tropical cyclone as seen on satellite imageries. A different type of satellite imageries are there. So let's make full use of it, both interactive, and I'm sure Shibin will be able to bring this interesting aspect of the tropical cyclone with respect to the satellites, which have been a great help in monitoring their development, movement, and so that is a very important aspect, the success of satellite meteorology in its application of cyclones. So over to you, Divya, and wish that this is a very, very useful session.
Thank you, sir. So Lakshmi Kumar sir, I think not available. So now Someswar Das sir, are you available? Do you want to say something to our participant?
No, that's okay. I mean, please continue.
Okay.
It's great pleasure that the lecture is going on smoothly, and today is the 16th lecture. So after this, 4 more lectures will be left. Already, this is second lecture of Shibin, and this is supposed to be more on a hands-on practical. So the participants hopefully will be able to learn the things practically about the products from satellite or the tropical cyclone products. And also I could just quickly see the YouTube views of the last lecture. I mean, the last lecture of Shibin was viewed by more than 150 people on the YouTube after his lecture. Of course, besides the live attendance, which the participants may be attending live. So more than 150 people attended his lecture, viewed his lecture on the YouTube, and it will obviously increase with the time. So rest of the things are all known. Even Shibin's second lecture and all the participants know about the rules and regulations. So that's it from my side, and on to you, Dr. Devi Prakash.
Thank you, sir.
You can continue. Yeah.
Over to you, Lakshmi Kumar, sir. So I think still there are some issues. So now I would like to invite Shibin Balakrishnan, sir, for delivering his talk.
My screen is visible?
Yeah, yes, sir. Yes, sir.
Okay. Thank you, Dr. Divya. Good evening to all of you. At this outset, I'd like to express my gratitude to Tyagi sir, to Bhatia sir, to Someshwar sir for giving me this opportunity once again to give my insights on the tropical cyclones and how our satellite observations helping in forecasting the tropical product. My previous lecture last week, this is for the participants who didn't attend or were not able to attend my last lecture. It covered the overall aspects of tropical cyclones, the global climatology of the cyclones, how are they forming or the ingredients, and what are we looking through satellite by identifying the tropical cyclones. So this today's talk will be again about the identification of cyclones per se from the different satellite instruments. I'll say different satellite platforms, and Dwarak technique will be explained and how it is used for your cyclone detection, intensity tracking, and followed by case studies. So this is again like the broad aspect which I had covered during the last lecture, where I had given an explanation or the basic idea about global climatology of tropical cyclones, how and where do they form, where not they form, and what are their role, the basic ingredients which are required for the formation of cyclone, the impacts of tropical cyclones during landfall and over the areas where it affects, and how are the different data platforms, specifically like satellite data and remote sensing activity being used for detecting the changes in the tropical cyclone. So today's lecture will be again more or less like how Someshwar Das had informed. It will be kind of a overview about the tropical cyclones or the different features associated with the tropical cyclones. How are we identifying these features from the satellites? The satellites per se, the different satellites at different platforms like geostationary or polar orbiting, etc. And what are the factors which are involved in these intensification and weakening? And how are we using the Dwarak technique for location intensity tracking of the cyclone? Okay. So this is a figure again taken up from the WMO report, where you can see the entire region, global region, delineated into different sectors for tropical cyclone. You can say the tropical cyclone identification, or you can say detection and monitoring and issuing of related warnings. So the North Indian Ocean, bound by you can say the regions along the Bay of Bengal and your Arabian Sea, they are bound by Regional Specialized Meteorological Center, Delhi. All the countries adjoining the North Indian Ocean is warnings and specific bulletins, other information are provided from Regional Specialized Meteorological Center, Delhi. So this is again a recap of what we discussed the last class. Like why do the tropical cyclones form over these regions? They don't form very close to the equator, like we saw Coriolis force coming into play. The maximum intense activity mostly confined over the west northern Pacific, and activity or the difference in the tropical cyclones over the North Indian Ocean, like Arabian Sea and Bay of Bengal, and why are more tropical cyclones confined to the Bay of Bengal, right? This is again a work which I have taken, which shows about the more or less the major activity which we are considering about the North Indian Ocean, the waves which are modulating or impacting the tropical cyclone, which was believed in the previous studies and the recent studies, attributing it to the you can say your Rossby waves and your mixed Rossby waves. Along with this, the right figure is again just showing, giving me information about the tropical cyclones acting as global heat regulators. This is animation which I had taken from Cyclone Haru of 2005 in North American region. So you can see this is the SST map which is overlaid and the animation which went through. The cyclone picking up the tropical cyclone as and when it is moving along, picking up the heat and taking up all the way up till the poles, and you can see comparatively warmer temperatures here acting as a regulators over the region. Coming to the tropical cyclones from a satellite perspective, there are various channels which we discuss in satellites. Channels are basically the different bands which we trap through the electromagnetic spectrum. From your visible image, your visible imagery, your infrared imagery, your microwave imagery. So we are using a composite of these different, I'll say different bands to identify or to narrow down the center and the tropical cyclones. I can say the center of the system. Like we know, the visible and the infrared imagery, you get these imageries are obscured. They not give you the information which is beneath the cloud structure. So there comes into play your microwave data or microwave imagery, which can penetrate through the cloud information and give you the eye, or you can say the center of the cyclone, along with the location of your LLC or low-level centers, which can help you in identifying or giving you, it gives you a information about the evolving of the structure along with your time frame. This is just an example to show you about the CDO pattern. I'll be discussing these patterns ahead. This is just to show you how enhanced IR image of a particular image in 99, followed by your PM or passive microwave imagery from TMI, showing you the center or the obscured area from the previous image. So these are few you can say attenuation methods, I'll rather say, which are affected, which affects the I'll say the information which we are tapping from the satellite information. Discussing about scattering, again, it is caused by, like we all know, by all these hydrometers or ice particles, snowflakes, etc. And the energy which is emitted from below is again which has a role of a very low brightness temperature. And coming to the different bands of microwave, like 37 gigahertz, 85, 81, 91. So they are pretty much dominant with respect to the scattering component. Coming to the emission component, like we all know, all these cloud droplets and water and rain emit your microwave radiation. And these effects have and emission is again pretty much prominent with all the images or all the data in these different frequencies. Polarization, when we talk, this is again, I'll rather say your specific to your polar data which we use, where we have different polarization, like we call VV, HH, HHVV, where the polarization again has a major impact on the 35 gigahertz and the 85 gigahertz with respect to identifying the intensity and the center of the cyclone. Again, now when we are looking into the rain events which are associated with the cyclonic event, and how are the geo and the LEO platforms playing a role here. Like we know, geo platforms are the geostationary platforms. Like you have data from the inside 3D, 3DR, the GHOST platform. So all these are data which we receive from the satellites which are stationary, or rather say relatively stationary at 36,000 kilometers above Earth's surface. And with this geo framework, we get a continuous time-bound information Whereas in the LEO or the lower Earth orbits, which are mostly confined where you have your polar satellites, they have a comparatively lesser temporal resolution with respect to the movement of the satellite, and it is basically 1 or 2 at the max over a particular region. So the limitations of this, again, like I just mentioned, the number of microwave-based satellite sensors, and when you have the system at a shorter scale, you are again bound to the IR or the information from the geostationary platform, and again the difference, the time gap between the different microwave imagery or the data is difficult to comprehend your particular system if you are going to use it at a I'll say a single basis rather than having a composite of your visible, infrared, and other data from your geostationary platform. So how do we utilize the microwave data? Like I just told you, microwave data, it can give you information which generally get obscured in the visible and infrared imagery. So like these have different BT or the brightness, temperature, emissivity ranges. And when we are looking into different channels like 87, 85 to 91 gigahertz, they are mostly confined to information at the middle or the upper level, and they can give you, whereas the 37 channel can give you the low level feature, which is giving you the low level cloud or center position. These images again depict the left one depicting your 85 gigahertz and the right one depicting your 37 gigahertz. So you can see the eye here in both with the difference in brightness, temperature, ocean having your comparatively lesser light blue because it is having lower brightness temperature, or it has less emissivity values, and cloud bands here, which is shown here on the right hand side. With the 37 gigahertz, you can see a distinct eye along with the outer band network of the clouds. Okay, so this is one of the example which I thought I'll give to whomsoever are participating. You can just look into this image and give your reply in the chat box. So I have just demarcated 2 arrows here. So you will just let me know what are these arrows depicting, and what is this cyclone, or what is the cyclonic circulation? How is this cyclonic circulation distinct? Okay. I think I'll give 5 seconds. You can just analyze this image and you can write your answers in the comment box. Fine. Okay, we'll go to the next image now. This is again with respect to your channel based use here, where you can see the eye, the eye and your second, you have an eyeball and there is a secondary eyeball which is developing. So I will explain this primary and secondary eyeball in the upcoming slides. So then the right image is corresponding to your smaller eye, which is replaced with your larger eyeball replacement cycle, which is more or less confined here. What is eyeball replacement cycle? How is that you see a smaller, I'll explain this with an example in the upcoming slide. What do you mean by eyeball replacement cycle? This is again your 85 gigahertz product, followed by the left one, which is your composite image of infrared. The 85 gigahertz product is giving you a clear-cut indication of your eye, whereas eye is obscured in the product on the composite image. Okay, so this is how we have we can kind of comprehend about the different types of, you will say, the imageries, or I'll say platforms, how we use to categorize the eye or identification. How do we identify the cyclonic sensor? What are the methods we use, and what is the how do we proceed further? So this is broadly a diagram which I have taken from previous slide from cyclone division. So we initially analyze the visible and IR imagery from the available INSAT framework data, applying the Dvorak technique, followed by the availability of microwave imagery. Like I told you, microwave imagery is again swath-based information which is available twice in a particular calendar day. So then we compare the 37, 85 gigahertz, and comparatively, then we form a center when the data is available. Then we have the radar imagery. Again, the radar imagery synoptic data again comes into picture. The radar imagery, let us say, it comes into picture when the system is close by to the coast. Synoptic data, again, this information is obtained when we have any data like ships or buoys in the deep ocean or when the system is near the, you can say the coastline, right? So based on all this information, we find or we optimize a particular center and come up with the intensity, or I'll say the center of the cyclone. So how do we locate the system center? What is the weightage which we give to different data platforms when it comes to identification or demarcation of center? So this is again very important because in the last class somebody had asked me how do you comprehend which tool to use for identifying a center or the weighting. So when the system is far away in the deep ocean, so we have only satellite data which is available and it gets more weight, and the position is again with respect to availability of more buoys or ships modified, but the maximum weightage is given to the satellite data. Let us say system is approaching or it is coming close to the coast, and if there is a radar coverage available, radar data gets more preference than your satellite data. Let us say system is very close to the coast or we are expecting landfall very soon, then you have the maximum priority given to the coastal observations over the coastline, which gives you, you can say the wind information, the pressure, the 24-hour pressure fall, and your systems information, followed by which we look into the radar coverage and the satellite data. Again, during the landfall time and during the, you can say, moving of the cyclone over the land, you have the availability of your AWS data and the coastal observation, which gives you more weightage or more value to the exact location of your center. Right. So this is with respect to the determination of the intensity of the system. Like how we initially look into the satellite-based intensity, we derive the 3D-based, the Dvorak technique, then we compare it with the other T numbers from different agencies like JTWC, CIRA, NOAA, etc. We get an intensity. Then we have the different products which are available from your microwave platform, like microwave imagery is at 85 gigahertz, 35 gigahertz. Then you have the satellite-based winds. Then again, when it is again near the coast, you have the radar-based information and ground-based information. And with these all information, we finalize the intensity of the particular system. So how do we measure the central pressure? Because the central pressure is again estimated with respect to different levels which we use, where we initially examine the mean sea level pressure data, which is available from your observations like buoy or you can say ship or coastal inland around the low level cyclonic circulation. And this is again analyzed by drawing two, you can say isobars at 2 hectopascal interval and finding out the outermost close isobar and with the difference giving you the, finding it out the estimated central pressure, comparing this estimated central pressure with your ground truth value, which is your buoy or ship, to optimize the exact value. Okay, so these are, I just broadly gave you an idea about how are we identifying the center, how are we identifying, estimating the central pressure, how do we kind of come up with a particular value for your tropical cyclone intensity. What is the Dvorak technique? I'll be discussing that in the upcoming slides. So it is again a statistical method which is used for your tropical cyclone identification from the satellite imagery. So the Dvorak technique or the initial Dvorak technique uses the your visible and infrared channel imagery for your intensity values identification. So based on these values on the cloud pattern, a particular value, or we can call it as the current intensity, is derived, and that is finally comprehended into the center of the cyclone. So what does Dvorak technique not consider? It is not actually a direct measure of any of your variable like wind or pressure, and it is not a replacement for your in situ or a ground truth measurement for a tropical cyclone. Right. This is again just an example which I had taken, where you see different types of cloud banding here with two cyclones in the you can say ES, Katrina and Beta. So this is the corresponding the cloud banding and the cloud pattern. I'm giving it to you in the upcoming slides. This is just to give you a picture about what are the different formation of the clouds, or I will say the pattern of the clouds, and how do you fit in those clouds into the T number information, right? The Dvorak technique the initial Dvorak technique uses visible and IR imagery, and you have the different patterns or different cloud patterns which are categorized. Like you have the curved band pattern, you have the shear pattern, you have the eye pattern, and then you have the CDO, the central dense overcast pattern. So these are the IR and visible channel. With these channel information, you are able to with this pattern, you are able to kind of comprehend what is the or where is the exact center from the satellite data. Okay. So this is again the people who are participants who have gone through the cyclone bulletins or the from the national agencies or international agencies would be aware of the TC intensity, or we will say the TC intensity from the Dvorak technique, which is called the T numbers. So the final T number is what I call as the CI, which is the current intensity number. So it is from the final number, which is again a aspect taken up from the data number, the expected T number, and the pattern number. Right. There are around 10 methods or 10 procedures which we follow for identifying or delineating the center from your Dvorak method. Identifying the center initially, that is the initial step where you identify or locate the system center. Then followed by that, you are finding or selecting the cloud pattern. How is the cloud pattern? Does it come under your, I'll say your curved band pattern, or is it your shear pattern? Is it your central dense or CDO pattern, or your eye pattern? Followed by that, you apply your central pole cover area, whichever is available. Then you analyze the last 24-hour trend of that particular product, assigning your model expected T number, or which we determine from the center of the eye or involvement with the dense forecast. Then we look into the pattern T number. Like I told you, how we identify the intensity. Based on this, we are using the data T number and the model expected T and the pattern T, and all these values we are able to finally get a final T number. So then we have the constraints which we are applying, which to get the, I'll say the current intensity or the CI number. So all the terminology which I discussed prior, these are the basic or a simple understanding of what do those mean from these Dvorak techniques. Coming to the CSC or the Cloud System Center. Cloud system is again, you can broadly consider this to be the eye of the system. The CDO, the central dense overcast, is again a band of clouds which is covering your eye or the whole system, and it is lying within the cyclones, you can say the band. Then you have the CCC, which is a fold cover. This is again a dense cloud which is obscuring your cloud system center. Then what is the current intensity? It is the final output of the Dvorak technique which we use and to estimate the intensity of the cyclone. Similarly, the number with your data T number, which you estimate from the available convective cloud band. Then you have the pattern band, which is again the intensity estimated from the different cyclone bands. Similarly, you have your model expected T, which is a 24-hour T number used for determining the intensity trend. And finally, you have the forecast intensity trend, which is your 24-hour intensity forecast, which you are getting from the current intensity in the cyclone band and environment. Okay, this is again a part of that. So how do we look into the, or how do we locate the eye, or you can get the cloud system center? So these images I've just taken for visual representation, where you can see the eye. You again observe the eye with the features available along the eye, and we look for the possible center. And again, eye is a pattern which we get when the system is totally, I'll say, mature, or when it is completely intense. Is the eye pattern which we observe, right? So this is again a CAC identification method. So you can see this cloud and the corresponding right visualization. How do we identify the cloud, or how do we come to a conclusion about the identification of your intensity, or I'll say the eye of the system? These are typical information from your CDO and shear pattern, and how the eye information or the center of the particular cloud band is associated with. This is an example which again depicts your low-level center in the shearing pattern, which shows the low-level center, which is side of the strongest convection area. And this is again giving you information about the distinct eye, which you can see on the left. And the image below is your the enhanced IR-BD curve. The right one is your ragged eye, where eye is not very much distinct here, followed by the BD image which is given below. So this is the CDO pattern which you can see. Like I told you, CDO pattern is again where you have the your developed area of the eye is basically obscured with your dense cirrus cloud, which is the CDO pattern. CDO pattern is again, like I told you, like visible in IR, we have this limitation of the values not being able to available at this level because we have these cirrus clouds which is obscuring the values. So you can see the IR based values which you're not able to exactly comprehend about the eye or the center of the system. So this is again the log spiral which we use for understanding, or I'll say the coming out with your T number if it is in your shear band pattern. This is followed by this. I have just taken up cases of your tropical cyclone. So this one which I'm showing here is the case study of Nargis in 2008. So this is from Google Earth which I have taken. You can see the system which is the Central Bay of Bengal, and it is heading towards your eastwards all the way till your Myanmar. This animation which I'm showing here is the mimic product, which shows you your eye information. So this is again generated with around 4 or 5 composite Leo data information at 15-minute interval. So if you look into the system, or I'll rather say the center of the cyclone, which you can see here, the center of the cyclone is initially developed, and you can see prior to landfall, the center is showing weakening and again intensifying. So this is a very distinctive feature of eye wall replacement, which you can see here. So here what happens? This eye wall is basically, I'll say it is merging up with the outer cyclone bands and intensifying and proceeding towards the land. So this is what is referred to as eye wall replacement, right? So there was again one initial period. There was a project Storm Fury, which was taken up by the United States to use with the usage of aircraft reconnaissance data and your seeding methods to see whether this cloud banding is normal or is it as a part of your tropical cyclone dynamics. So they had finally, I'll say the project was completed, and it was kind of understood the eye wall replacement cycle is not because of your seeding. It is a part of your normal tropical cyclone dynamics, where you see any system or any tropical cyclones which is above, let us say, 200 kilometers per hour undergoing rapid eye wall replacement cycle. Now we look into the practical exercises. So this is again for the participants. I am showing you a figure here. You can all see on the right side here. I am giving you the SST values here. SST is, let us say, 26.5 degrees Celsius, and the shear magnitude. I had discussed about the impacts of shear over the intensity of a tropical cyclone. So based on this SST and shear information, I'd like to give your answers for this particular figure. So these are the 4 options which we have. So you can, looking into the information picture here and the information available, you can provide your answers. What do you feel would be the correct answer for this particular system? One more example which I'm giving here is again another system which you can see here. Here you can see the system, and you have SST at around 28 degrees Celsius with shear magnitude of 10 meter per second at 658 hectopascal here. So here with this information, again I'd like to I like your answers about all these 4 options. What do you feel with this particular environmental parameters the system would have experienced? This is a recent case study of 2019, where we have seen the INSAT 3D image followed by a microwave image, where you can see in the IR image that this is again the nighttime image, early morning. You don't see the center. Center is obscured in this IR imagery, whereas in your microwave information, you have the center clearly pointed out from this particular satellite platform. Like I told you in the last class, we have this usage of, we are using scatterometer data also from ASCAT, and of late we are also using scatterometer data from ISRO to identify or to get us the information about the center, or I'll say the with respect to the wind pattern, the circulation and the probable center from the scatterometer wind. Like I told you again, the scatterometer or the ASCAT passes are has a very low temporal resolution compared to your geostationary platform. Nevertheless, we get a very clear indication over this when we get this data over a particular center to identify the center of the system. So this is again another image which I have taken comparing 3D and the microwave data. So again, you can see this is the same system which I have taken, which is near the land. You can see the IR information, not able to give you a particular, I'll say the I information or the center of the cyclone, whereas your microwave at 91 gigahertz is giving you the a comparatively better signature of your I. This is the shear pattern example which I'll show you. And to keep it in a little more simple way, like all the patterns which I've discussed, the shear pattern, the I, the TDO pattern, so they are formed at particular stages of a cyclone. Like you can say the shear pattern. So shear pattern is again followed by your curved band pattern. I'll take you through these images and then I'll explain to you how do these patterns form and with respect to what would be the intensity of the system. This is the curved band pattern which you see here, followed by your central dense overcast and your I pattern. So when we look into a cyclone, overall cyclone right from its genesis till the weakening or the dissipation of a cyclone, to keep it simple from these patterns which we observe, if I have to categorize the formation of the pattern with respect to the cyclone, I can say the initial stages, or I'll say the early stages of tropical cyclones, you see the curved band pattern. Curved band pattern is seen where you have the cloud bands which are curving towards the particular central, let us say the low level cyclonic circulation. Then you have the shear pattern. So shear pattern is again where you have a cyclone which is already formed, and you have the I'll say the deep convective clouds present there. And this is again, you can classify this or identify this with respect to your log spiral information. This is followed by a CDO or a central dense overcast, where you have the high cirrus clouds which form as the core of your the tropical cyclone which is present and is also in the available in seen in the stronger tropical activity. Followed by the CDO pattern is your I pattern. The I pattern is an example which I've just shown you here. I pattern is again indicating the maximum, or I'll say the distinct I which you can see here. This figure also we can quite visible. I pattern, it shows you the proper intensification, exact system, entire system along with the information of the I. Clear? So yeah, so this is the I think if you have answered it well and good, otherwise okay. This is what the previous figure corresponded to. The example, the exercise which I had given. The first point corresponds to the I and the eyeball, and the second demarcation is the associated rain bands along with. Another question which I had asked was, what is the distinct feature of this tropical cyclone? Because all the examples which I have dealt with in this class and the class prior, I had shown you the tropical cyclones mostly confined to your northern hemisphere. So this is a system when you look into the lat long information, you can comprehend. This is a system which I had specifically taken from the southern hemisphere to show you the cyclonic circulation here, or I'll say the clockwise movement of winds here. So this is again like we saw in the last class how tropical cyclones in the northern hemisphere have your anti-clockwise circulation, and similarly in the southern hemisphere it has a clockwise circulation. So this is a pattern which you see in the southern hemisphere. Just to give you an example or keep a distinct example, I had taken this image. The second example which I had given was the shear pattern. So this is a information which you have taken later. So you can see the storm with respect to the high values of shear and SST. So there is no information. It sees that this is the disorganized pattern which we are seeing in the later stages, and the system is already weakened. We had given one more example which we had asked about the intensification or the nature of the storm. For the answer for that is the storm has intensified, because this is a 72-hour satellite image later, which we have seen to comprehend that. So you can see a clear-cut eye information here. The SST is warm, and it is providing, or it is fueling the system to intensify, or it has already intensified over this particular region. This is again just to give you information. The left animation being the Himawari data over cyclone Varda, which made landfall over North Tamil Nadu, and the right one is the information about a peculiar, I'll say a peculiar tropical cyclone activity which happened near your equator region. Both there were two systems which originated. One was the northward propagating system being Fani, and the southern one was Lorna. The southern system more or less weakened after some time, whereas the northern part intensified with proper passing through proper environmental conditions, and it made landfall over parts of northeast India. Thank you. If you have any doubts, any questions, you can raise it to me. Hello? Am I audible? Hello? Hello?
So, Dr. Divya Prakash,
Hello?
are you there, Dr. Divya Prakash? I think now it's time to take up questions and answers. So, Dr. Divya Prakash can read the question and you can answer perhaps. Okay.
Hello.
Yes, come. Okay. I think now it's time for question answer session.
Yeah, so before proceed to question answer session, I would like to request to all panelists to switch on their camera.
Okay.
Thank you. So first of all, thank you, Shibin sir, for delivering this wonderful lecture. I hope a participant has enjoyed and learned a lot from this lecture. And if they will face any issue, then they will contact you by your email ID.
Yes.
Thank you. So there are some questions I am just asking. So today we don't have any question from participant. Actually, I think because you have delivered this lecture very very insightful manner. So I hope all the doubts of our audience is cleared. So now today there is no question. So,
I would like to
sir,
cover basic aspects of
yeah.
satellite-based thing. If
Yes,
any
sir.
question per se, anybody has any queries, they can always mail to me. I've mentioned my mail ID also.
Yeah. Thank you.
Thank you.
Wait a minute.
I have one question for Dr. Shibin.
Yes, sir.
My question is regarding the use of rapid scan imagery for cyclone analysis. Now, I understand that in case of every cyclone, you are taking every 6 minute scan or 5 minutes. Maybe I think it is 4 minutes, not 5 or 6.
4.5 minutes. 4.5
Four and a half minutes. What they call sector scan.
Sector.
Okay, where you can view an area more frequently.
Yes, sir.
So, and I understand every time there is a cyclone, you are viewing it with better time resolution
Yes, sir.
and doing some adjustments in the center and using rapid scan. So I would like to know whether what are the adjustments you are doing using rapid scan imagery data in the analysis.
Sir, in the analysis per se for rapid scan data, we are again deriving a few geophysical parameters with the rapid scan,
Okay.
like the BD curve, the NHE curve,
Okay.
where we are able to get the eye information when we have a cyclone, because
Okay.
rapid scan is generally initiated after a depression stage.
Okay.
So when the system is already well established, so we are able to get this eye, or I'll call it as the center of the system, at a much faster, because at half an hour interval and 5 minutes, so we are able to kind of understand, is it actually the intensity, or what is the pattern of the system? Is it going ahead? Is it stationary? That information is available from the rapid scan.
Okay. Okay.
Time to vote of thanks. Dear sir, am I audible?
Yes, yes.
Yes, you are.
Yeah. Am I audible?
Yes, yes, you are.
Sir, am I audible?
Yeah,
Yes.
Divya, you are audible
You can
and
he-
you
I can
go
hear
ahead
you.
with the vote of
Am I
thanks.
audible?
Yes, please go ahead. I can hear you. I am sure others also can hear you.
Am I audible?
Yes.
Shibin sir, am I audible?
Yes, 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 you're audible.
Okay. Yeah, just now I am just sharing. Yeah. So, dear amazing participant and special guest, a big warm thank you for being part of this our absolutely fantastic 16th session in the Satellite Weekly online lecture series. We had the pleasure of pitching into the fascinating world of tropical cyclones with the incredible Sri Shibin Balakrishnan, a true master in this field. He had understanding these storms with satellite observations feels like magic. The real examples and hands-on tips for real-time forecasting made the whole experience not just educational but downright gorgeous and inspiring. The Imagine exploring tropical cyclones as if you are unlocking the coolest secrets of weather with super user-friendly tools. Shootouts to our fantastic Sama ECT members, Dr. TV Lakshmi Kumar sir, and for leading the session smoothly and sparking those engaging discussions. To our wonderful global participants, your diverse contribution turned this session into smoothing truly special. A heartfelt thank you to ABM Professor Dr. Ajit Tyagi, President Sama, Professor Dr. Someshwar Das, and Dr. Swagata Paira, convener of this lecture series, for being unwavering pillars of support on this enlightening journey. Thank you for joining us on the enriching exploration into the dazzling world of satellite meteorology. May the incredible insights gained today guide us to even more gorgeous discoveries in the future. Warmth and appreciation. Thank you.
Thank you, Dr. Divya Prakash, and once again, thanks to Shibin, and request participants if they have got some questions or would like to know more about application of satellite in monitoring and prediction of tropical cyclones may directly contact Dr. Shibin.